three main measures of central tendency: mean, median, and mode. And everybody always thinks that the mean is the most important of those three. That's not the case. All right? You've got it beaten into your head through 12 years of schooling that mean is the best because that's what we use to figure out your grades. And that's not always the case. That doesn't always necessarily mean that's what you know. Don't think, though, that I'm going to change the way that I grade because that's the way it's set up and that's the way it's going to stay. So I don't want Lucas in here going, well, why do you use the mean? You said it wasn't the best. Why don't you use the median and get rid of some of these lower grades and only go by what I did the most? Or
That would be smart.
So then it would be, if we decide to use the mean, median, or mode, whichever one worked out best for you, what I would have is Sydney up here would score a 95 on the first test, and then for the rest of the year she'd be trying to score a 95 on every other test, and then once she did that, she'd make sure she scored like 20, 32, so that came out to be the mode, and that's the one that I would have to use. That would be. What we're going to learn: how to find the mean, median, mode, how to find weighted means. This is probably the hardest thing that we're going to do today. Not really hard, but you got to make sure you know some of that other stuff that we've been doing with the frequency distribution. How to describe a shape. This is very, very, very important. How to describe a shape. We're going to talk about these. There's actually 4 different ways a shape could be described. Measure of central tendency. We talked about this a little bit last time. Most common, those 3: mean, median, mode. The mean, add them all up. Mean, you add them all up, divide by how many of them there are, how many entries there are in the set. Same as before, when you found mean. Before, mean was always called average. Mean was always called average before. So the sum of all data is divided by how many of them there are. Average, I do not like this word because all of these are averages. But that's what most of you know mean by, is the average. Some of these different notations that we're going to use. Remember, that's a summation. That just means you add them all. Summation. So when you see this, that's actually called a sigma. It's a Greek letter. Sigma x, that means you add up all the x's. Whatever all the x's are. X will usually be your entries. X is usually what stands for the entries in your set. We will take, and if you notice, well, it's not on there, but on Moodle, if you look down through there, it says symbols test or symbols quiz. I can't remember which one it is. Probably next week, we'll start having symbols quizzes, and we'll have them periodically throughout the year. That's one of the symbols that's going to be on there. So if you see that symbol and it asks you to define it, it just tells you add up all the data, add up all the entries. For population, we use what's called a mu. That's that symbol right there is mu, and that's stands for population mean. Population mean. So if you know all the population, if I'm dealing with all probability and statistics students, that's just all of you guys. So you would be my population. So we would actually be using mu. If there's a population mean, then that probably tells you that there's a sample mean also. Sample mean is this, and that bar is supposed to be there. That's called X bar. we use X bar a whole lot more than we will mu. Because we can find more samples than we can whole populations. Remind me next time not to answer the door in the morning, all right?
Get paid for it.
That's the thing, I don't ever turn in the money because I don't think you should. I sort of think it's my responsibility to do it sometimes to cover for other teachers when they're out because other teachers cover for me.
For a change, I take the money from them.
But if, I don't think that if we're doing it in-house, that we ought to, that we should get paid for it. I think it ought to be somewhere you're doing it just because you work here. But a day like today, one of the days where I really don't want to do it because I have a whole lot of my own stuff to do. When figuring, or when finding the mean, round your answer to one more decimal place than the data values. So if all your data values are like this, 2, 4, 6, 8, when you find the mean, you go out one place behind the decimal. All right, so you go out one extra place every time. Also, use your calculators. Speaking of which, oh, it was Dalton, you're gonna get one, right? I looked, I haven't found anything yet, but I will. Only round when you reach your final answer, so keep your numbers on your calculator and just keep punching in. You'll do like, add up all these, then you'll divide by this, then you'll times it by this, and it'll always be right there on your calculator. So don't round off until you absolutely have to. That's going to make your answer as precise as possible. I think we did this last time. Doing this, all we're going to do, prices for a sample round trip tickets from Chicago to Cancun are listed. What is the mean price? We're going to add them all up, divide by how many of them there are. We add them all up, get 3,695. Then we're going to divide by 7 because there were 7 of them. Remember, that's going to give us the X bar, the sample mean. Because we're not doing all flights in all of the world. We're just doing a sample of them. And the mean price, the sample mean price, or the X bar price is $527.90. So if we're going to fly to Cancun, we can expect to pay $530 probably. Somewhere around that area. What would make these prices different? How come you got a price that's $397, then you got a price that's $872? Where you're flying from. All right? If you're flying from LAX, it might be one of these lower prices because they have more flights actually going to Cancun. If you're trying to fly from Dayton, from the airport in Dayton, it's probably going to be one of the higher prices because they probably don't send too many planes out each day going to Cancun. This one, though, I think said it's from Chicago, all of one there or something. I don't know. Median. Median is the value that lies in the middle. First thing you got to do if you're finding the median is put them in order. Got to put them in order. I would probably put my sets in order anyway as soon as I see a set of numbers. If it's not 100 numbers. If it's 20 or 30 numbers, put them in order. First thing, that's going to make everything easier on you. And also, we're going to learn on our calculators. If I get my calculator, we're going to learn on the calculators. So now's the time to have your calculator. Make sure you start bringing it to class every day. Because if you get a set of numbers, you can punch them right in on the list. I gotta remember where all this stuff's at. You got your stats here. go to edit, it's got list 1, list 2, list 3. Well, I got a bunch of numbers in list 1. If I go back to stat and I go to calculate, and I calculate one variable stats, hit enter, then I hit list 1 is the one I want to use, and it pulls all this up, and Sydney's going to tell you what's the very first symbol, X bar. It tells you the mean, all right? And if we go on down through here, what do you think that MED stands for? Median. So if you can punch them in here, then it'll do all the work for you. And there's some of the stuff where you're going to have to punch them in because there's going to be other things that you don't want to try to figure out longhand. Measures the center of the ordered data set divided into 2 equal parts. So when we do median, 2, 4, 6, 8, maybe we have that, 10, we add a 10 on there. We just look and we say, okay, we got 2 on this end, we got 2 on this end. That number right there is the median, it's the one that's right in the middle. 2 different ways it could happen though. One way, if you have an odd number like I had right here, then there's going to be exactly one number in the middle. And you just put that number as your median. Let's say we got rid of this 10, that wasn't part of our set. Then we have 2, 4, 6, and 8. Then we have an even number, then these 2 numbers are in the middle. And what we do to get the median is we add those 2, so 4 plus 6, and then we divide that by 2. So our median in this case is 5. And your median doesn't always have to be a number that's in your set. So you add the 2 middle pieces of data and divide by 2. Everybody understand all the stuff about median? Pretty easy, Brendan. Prices in dollars, we got this. Again, first thing we're going to do is put them in order. We put them in order. Again, probably a lot of you have done this in the past when you dealt with smaller sets of numbers. You went like 1, 1, 2, 2. With the sets of numbers that we're going to use that got 30 or 40 numbers in it, you're probably going to get lost if you do that. So what I do is I count 1, 2, 3, 4, 5, 6, 7. 7 numbers here. I divide 7 by 2 and I get 3.5. That tells me, and I just round it off to 3. That tells me that there's 3 numbers from this end, 3 numbers from this end, and then that one's going to be the middle number. So 427 would be our median price. We got 427 here. We had what, like 527 something when we did the mean. Looking at that set of numbers, if you went out and just randomly bought a ticket from Chicago to Cancun, which number do you think you would be closer to, or which number best represents the actual price? 527 or 427? Because that's a pretty wide spread. I would guess the 427. Where's 527 fall at in here? Like way down here, right? So why might 427 better represent the... All right, it's closer to the rest values. What caused the 527? You got these 2 that were real high. They were a lot higher than the rest of them. As a matter of fact, they're double a couple of these down here for whatever reason. All right, so the mean's not always the best number. Sometimes the median's a better number to go by. We got rid of one of those numbers. Now we look at them and we got 6 numbers. Those 2 are going to be the 2 middle, so we're going to add those 2 and divide by 2, and that's going to give us, not those 2, they're not in order, are they? We put them in order first. Now we add those 2 and divide by 2, and that's going to give us the median. So $412, and notice that's different because we got rid of a number that's different than the other 2 even that we got. Mode. Mode's a piece of data that occurs the most. Mode is sort of the one that gets left out because nobody ever thinks the mode could be the one that's the best way to describe a set of data. If there's no entry that occurs more than all the others, then we just say there is no mode. So you could have one mode, you could have no mode. The other thing you could have, if two pieces of data, if two sets of entries occur the same amount and they're the most, then it's called bimodal. So we could have two modes. Once you get past two modes, we usually don't even bother with it. So you can't have 3 modes, 4 modes, 5 modes. It's usually none, 1, or 2. I think this book sometimes they'll put down 3 modes or 4 modes, and that's just sort of silly. If you got that many numbers that occur the same amount of times in a set, then just say no mode. There's not one that occurs more than all the rest. So if we're looking at this, you look through all these sets of data, you get 397's the mode. Would 397 better represent the rest of them than the 412 or the 5 whatever we can't 527 or the, would 397 be a good representation of this set of numbers? Probably not, because it's almost the lowest. All right, so sometimes mode will be a good number, sometimes like on this one, not so good. But you got to be able to decide that and that's going to be a main part of this. I know you can find mode, median, and mean. That's not something that I expect that you can find, or that I'm trying to teach you right now, because you should have been doing that for the last 5 or 6 years. What I'm expecting is, once you find that mode, median, or mean, understanding what they're telling you, and understanding, is that a good representation of your data set? Here, 397, probably not a good representation of the data set. It's a little on the low side. When we're looking at something like this, even though it doesn't look the same, it's still the same idea as far as finding the mode. You want the one that occurs the most. That happens to be the Republicans right there, because they're there more than anybody else. So you can still find a mode on some kind of table like this table. Why might you want to find the mode there? How come we might want to know that more Republicans replied to or responded to whatever it was? What might that affect? What if, let's say this was a vote. They're getting ready to take a vote in the Congress over this new health plan that they have. Somebody's proposed a new health plan, and they're getting ready to take a vote. Every time they vote, does every congressman or congresswoman vote? No, sometimes they ain't there and they just don't vote. All right? So if this is the vote, might that affect how the vote comes out? Yeah. There's 56 Republicans, 34 Democrats, and 21 other. Then that's going to affect how things come out. So you might want to know what had the most, or what was the most there. Talked a little about this last time. All 3 measures describe a typical entry of a data set. Advantage using the mean. Mean uses all the numbers. So it uses all the numbers to find the mean. Disadvantage using the mean. If you have an outlier, then that messes up the whole set. All right? Tried to talk last time about Michael Jordan and how he was an outlier on his salary his first year out of UNC with his degree. Made it look like anybody who earned that degree at UNC was going to average like $8 million a year. when they graduated with that degree, well, it doesn't work out that way. I don't believe for a minute that Bryce is gonna go to the NBA and make $20 million next year.
Maybe 2 years.
Yes, maybe, knock on wood. I don't say anything bad, but if there's some kind of massive destruction and then Bryce is playing in the NBA because all the people who actually play there now are no longer with us. Maybe, probably not. All three measures describe an average. They're all three averages. Don't forget that. There's all kinds of averages in math. Mean is not the only average. Mean's the most familiar. That's one we use the most. It's sort of a reliable measurement. That's why we use it more than the others probably. But sometimes it may be greatly affected by outliers. Median, common average, it's not affected by outliers. So if you have an outlier, sometimes it might be better to use the median. Mode, if there's if there's a whole bunch of one thing, then it might be best to use a mode. So sometimes mean, median, mode. And I can't tell you how to make that decision. You got to look at the set of data and decide which one do I think is best this time and why. Is there one big outlier that causes the rest of them to look off? So mean might not be the best. We talked about your grades last time. Sydney up here right now is all upset with me because I gave her out her interim report, and I'm going to put her on this video right now and tell everybody this. She's got that grade on the first quiz because she wasn't here to take it that time, right? So she's got that grade, and what'd that do to her whole overall grade?
Way down.
Brought it way down. Okay, so now she's not happy with me because on her interim report, her grade doesn't look too good. So she would have been happier instead of me using the mean if I sort of got rid of that grade and maybe used the median or the mode, right? Because that might show a little better what she actually knows about the class, not just the fact that she wasn't here that day to take that quiz. Because we have that outlier. Shape. The shape of your data and the existence of any outliers may help you choose the best average. There's going to be 4 different shapes here. These are very, very important. And we're going to talk a bunch about them. This is something we didn't get to last time. But just looking at these shapes, notice how this shape is. Notice how this shape is. Notice how this one is. And then there's going to be one other shape that we're going to talk about. This one's called symmetric. This one's skewed to the left. The way I remember this, see how it has sort of a tail? If it's skewed to the left, then the tail's on the left. If it's skewed to the right, then the tail's on the right. So skewed left sort of has a bunch of little data out here somewhere, and then it gets to where it starts going up in the middle here. If you're symmetric, then your mean, median, and mode will probably all fall right in there, right in that highest point. If you're skewed to the left, then your mean's going to be down this way a little farther. Your median's going to be more in the higher part. Your mode's going to be at the highest part. Over here, it's going to be backwards of that. Mode's going to be in the highest part here. Median more this way, and the mean will be pulled more down towards the right tail. So we're trying to find the mean, median, mode of this set of data. I'm just going to go through this real quick. Ages in a class. Hopefully these aren't your ages. We add them all up to find the X bar, so the sample mean, and we get that the sample mean is about 23.8 years. The median, if we put them all in order, which we have here, we got 3, 6, 7, 20 pieces of data. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's the 10th number going that way. That's going to be the 10th number going that way. Since there is no one specific center number, we add those two together, divide by 2, and you get 21.5. Mode. Anybody tell which one the mode is just by looking at it? 20. 20 is the one that occurs the most, it looks like. Now, when we're looking at all three of those, which number best represents that data set? If I had to say, people who took probability and statistics normally are about this age, what age would I say? The median, maybe? Yes. Yes. Yeah, we could do that. All right. Thank you very much. So, which one did you say? Maybe the median. I might even go with the mode. Probably not this one. How come not the mean this time? You got this person that's 65 that's going back to school, making the age look like it's higher than it actually is. All right? They're a lot older than everybody else in the class. Saying all the stuff that we just said. So sometimes graphically, if you were to show this graphically, notice where the person is that's 65, you have this big gap in between them and everybody else. Weighted means. Might want to write some of this down while I'm trying to get these. I went too far. While I get these set up for these two people coming in here. Let's see. Lay it on my chair. Oh, do I need to work?
Well,
Or the other part? Peyton, I laid yours back here. Sam, yours is there behind sleepyhead Dalton, laying his head down. So weighted means. Weighted means a little harder to deal with. You got to know how to find a weighted mean. You guys are allowed to use a calculator, one sheet of paper. mean of a data set whose entries have varying weights. If we do a frequency distribution chart and we're like 0 to 7, 8 to whatever, it's sort of hard when we do our frequency. You know, this is maybe the frequency of that first one is 5, because you don't know, what each of those numbers were. So what you actually use on that, that's where we use the midpoint again. We take the midpoint times the frequency, and that's going to give us our number that we're going to use for that set. Now I'm going to show you an example of that here in a minute. Remember, this is X bar. That's our sigma. Sigma, is that right? That tells us to add all those up, add all this up, all the weighted stuff. In this class, your grade is actually weighted. All right, 70% count, or tests and quizzes count 70%. The homework counts 30%. If you're taking a class, you go off to college next year, a lot of professors do it this way. They'll tell you right up front, this is 15% of your grade, this is 20% of your grade, this is 5% of your grade, this is 80% of your grade, so on, so on, so on. Is that the calculator? Yes. I could understand it. It's not smart enough, I don't guess. So they'll do that right up front on the syllabus. They'll tell you exactly, these are where your grades are going to come from, and this is how much each one's going to count for your grade. So when I got my syllabus or syllabi when I was in college, and I looked over this and I seen something like this, 5% from homework, probably means I didn't do the homework in that class. All right, might have done it but not put a whole lot of effort into it, because it was only counting 5% of the grade. Put a little more effort into something like this that was going to count 50% of my grade. And then if I wasn't good at tests, then I looked down through here and found out stuff like those and said, you know what, that's 20% on that final exam. I better bust my butt on that because I didn't do so well on some of the other tests. If we're looking at all that, here's your scores that they had on there. All you're going to do, you're going to take that times the score on each one of them, the percentage times the score. Take all those numbers, add them all up. And that's actually what we do in here. Except I find the average of all your tests and quizzes, times that by 70%, average of all your homeworks, times that by 30%, then I add just those two numbers up. So I don't separate it, so each thing counts something separately. Notice, what's this say down here? Total of all the weights should equal one whole. So if you total up all these, you got a professor, and you total up all their weights, all their percentages, and it comes out to be 120. You need to have a talk with them and say that they need to go talk to their math professors on campus, because you can't have 120% of an overall grade. So we average all that up, you end up with a 88.6. These are your grades in here. What I do with this, I look down through here, and on yours now, it actually tells, I think on Moodle now, they give like a percent out here, don't they? A percent. I think some of them give letters too. I don't know. I wish they wouldn't put that letters on there. I don't know how to get rid of it. But some of them give letters, some of them give percents. So it's just telling you the percent. If you look at that and you average all those percents together, and let's say you got 100% here for all your homework grades. Here looks like a 79. I don't know what that quiz was out of 4. Let's say that quiz was out 4 out of 4. So your overall average here would be about an 80% on your test average. What you do is you take those, multiply them together, take these, multiply them together, then you add those two answers, and that's going to tell you what your overall percentage is. That's a weighted average. Certain things are weighted a little more than other things. Mean of a frequency distribution, this is important. When you're doing a frequency distribution, you're going to do the sum of the x's times the frequency. This x is the midpoint, or the midpoints of your data. So the midpoints, actually let's not even put that on there, midpoints of the classes. So midpoints of the classes. You guys weren't doing anything in there in that class today?
No, we're on the resumes for things we're due in a couple months.
What, chemistry? I do or slam, I do nothing.
I think he's talking about ag.
Are you wearing,
Oh, this.
are you wearing off on Lucas? Just throwing in random stuff that doesn't have anything to do with anything.
It's still worth saying.
I'm going to show you an example of how to do this. Very important because we're going to deal a lot with, and I know all of you think, oh, you gave us that same silly quiz over frequency distributions twice just because you like to give us quizzes and stuff. Because I know that that's very, very important. Got to know how to do those.
You didn't mean to.
I didn't mean to. Is that what it was? It was just a slip up, and I didn't want to tell everybody that I messed it up.
I'll give you that.
So normally when you're finding the mean, this would just be the sum of all the x's divided by how many is in the set. When we're finding it for a frequency distribution, it's x, which is each midpoint, times the frequency, then we add all those up. So on your chart, you're going to have this. You got your class. You got your frequency. Now we're for sure going to have to find our midpoint each time. And all you're going to do is on each of those classes, if this one's 5, that one's 7, that one's 2, whatever the frequencies are for each one, we got to find the midpoint of each class. Remember, to find the midpoint of each class, you add those two numbers and divide by 2. So 0 plus 7 is 7, divided by 2 is 3.5. So all we're going to do each time, and we might want to make another column out here, and just call it x times f. We're going to take that 5 times that 3.5. We're going to write that answer in right there. Then we're going to do the same thing, write answer in there, answer in there. Then when we get down here at the bottom, we're going to add all those up, the sum of all those, whatever it comes out to be. Once we find all that sum, then we're going to divide. And what we're actually going to divide by is how many, the frequency over here, how many things are in the set. How many different numbers are in our whole set of numbers. This is just steps. We'll do a lot of steps. So here, to finding the mean of frequency distribution, number 1, first thing you do, you find the midpoint of each class. Number 2, you find the sum of the products of the midpoints and the frequency. Number 3, you find the sum of the frequencies. Add up all of them. Number 4, find the mean. Not sure why those are popping up that way. If you're using mu, if you're doing the whole population, it could be this way. It's a big N instead of a small n. All the big N means is that you know it's a population. The small n tells you that you're dealing with a sample. So notice these two formulas basically the same thing. All that changes, x bar, mu, x bar is for a sample. Yes. Yes. Sure. You got a sample there. This is the population. Same thing for the n's. A small n is for a sample, big N is for a population. We'll do a lot of stuff this year. I was talking to Mr. A yesterday. I like to list stuff out like this. If you write this down, this tells you exactly the steps. What do you do first? What do you do second? What do you do third? And I'll do a lot of this. You'll see a lot of stuff that looks just like this throughout the year, because I think if I give Sydney up here 5 steps, she's intelligent enough that she can follow 5 steps and do something. I said Sydney. And I said Sydney. Whose name did I not say? Didn't seem to like it so well when I turn his smart aleckness around when he does it. So if we have this, we're looking at this, our class is 7 to 18, 19 to 30, 31 to 42, 43, so on, all the way down through there. We add these two, 7 plus 18, divide by 2, that's 25, divided by 2 is 12.5, so that tells us the midpoint. We find all those midpoints for each of those classes. Then all we're going to do with that, we have our frequencies, we count it up, tallied them all up, whatever. All we're going to do with that is we're going to multiply. Those two together, multiply those two together, multiply those two together, multiply those two together, multiply those two, multiply those two, multiply those two. And that's going to give us another column out here where we can have, write all those down.
What would that be the?
What would it be? We would probably just title it X times F. So that would be that column, X times F. On these two columns, you're going to sum them all up down here. So you're going to find the sum of each of those two columns. Once you have that, add all those up, add all those up. Once you know those two sums, then we're going to divide them. So we're going to divide this column, the X times F column, by the frequency column. Just the sum of those. Whatever we get down here, we're going to divide each one of those. And this is going to show us how to do that. There it shows you the X times F, that column. We've got a total of 50 here. We got a total of 2,089 there. Then we divide those two, and our mean, our X bar of this sample ends up being about 41.8 minutes. So whatever this dealt with, I didn't read the original problem, it's something dealing with minutes. Whatever it dealt with, the mean is about 42 minutes. Maybe it's driving time for people to get to work or something like that. Makes sense? So if you can handle that, not too hard, right? Just adding another column to our frequency distribution chart. But you have to find the midpoints this time. On the other ones that we did, you didn't always have to find the midpoints. Symmetric, write this down. These are the 4, we're going to talk about 4 different shapes. So if you're making a graph, what's that graph called again? What kind of graph is it? Don't anybody dare say bar graph either. Histogram, thank you. Here, I won't make fun of you. You have a histogram. We make a histogram because it could make 4 different shapes, and those shapes sort of tell us something. The first one's a symmetric distribution. The graph is symmetric. These are very, 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 very important. We're going to deal with them all year long. What's symmetric mean?
Both.
So if I drew a
It's the same on both sides.
same on both sides. Now, in the real world, we're doing these graphs. Are you going to get something that's exactly the same on both sides?
No.
Probably not. So when we see something that maybe looks, if our graph looks something like this, we're probably going to say that that's pretty close to being symmetric, even though it's not exact. All right, it's pretty close to being symmetric. Because in the real world, not everything works out exactly. When you're symmetric, if it was perfect, the mean, median, and mode would all fall right there at that line. So the mean, median, and mode this time looks like it'd be about 8.5. A lot of the times we won't look at a histogram, we'll look at a graph that looks like this. So you need to know that not only could a histogram be that way, but if something looks like that, that's also symmetric. That also tells you that the data was symmetric. Uniform. What happens in a uniform distribution? Everything's the same. Again, in the real world, are we ever going to have something that probably comes out exactly the same? Don't you getting all this? Slipping on me, aren't you? You had a long night last night? Wife keep you up? Probably never ever going to have something that's exactly uniform. But if you have something that looks like this, we'd probably say that's close enough to uniform. Notice, if I drew a line right down through here, is this still symmetric? Yeah, so it's still symmetric. It's just a different kind of symmetric, or a different kind of symmetry. Next one, skewed left. Skewed left. Again, if you wanted to draw, instead of drawing a histogram, if you wanted to draw just a curve to show you what skewed left means, it would look like this. That's horrible. Wouldn't look like that. It'd look like this, where it has a tail down there on the left end. Skewed left will have a tail down on the left end. It's got a bunch of little stuff coming up, then it's got a whole bunch, then it sort of comes down on the other side with not a whole lot over there. So skewed left. Remember, when you have something that's skewed left, that sort of scoots the mean over there towards the tail, scoots the median over that way towards the tail a little bit. Then the mode is still where it occurs the most. So you got symmetric. What's the second one called? Because we don't ever use it. So uniform, skewed left, and this next one's going to be skewed right. So again, if you just wanted to draw a curve instead of a histogram to show you what it means, it's going to look something like this, where it's got a little bit of a tail going out that way. That's skewed right, positively skewed. I usually won't ever say negative or positive skewed. That's too confusing. Skewed left, skewed right.
What did we bring up here, class?
Do what?
What did we bring Katie about the beer?
I should. I can sit in here, just get my stuff done. Sit in there. I have done that in the past, but especially if it's ed class, they get mad at me.
Weird.
They want to actually do something then. Plus, I got 25 minutes right now that you guys are gonna be real nice, and I'll be able to get some of my stuff done. Right?
Yeah.
This is your assignment. Assignment I gave you last time. If you looked at it last time, might make a little more sense now, hopefully. If you did look at it, then hopefully it makes